All right, friends, it's your boy, Mr. Shagney, coming at you with Unit 3, Lesson 9, Creating Scale Drawings. In today's lesson, we're going to look at how we can create scale drawings, looking at two things, and then basically scaling Utah. So the first thing is a number talk. Number talk talking about which is greater. So without calculating, decide which quotient is larger. So when you have a division problem, we can write these as fractions. So this is 11 over 23 and 7 over 13. So how to think about this is that we know that 11 is not half of 23, but a little less than half. And we know that 7 is a little bit more than half of 13. So to give you some context here, what I'm thinking about is 11 is half of 22. So since 23 is larger, we know that this is less than half. And because 13 is less than 14, we know that this is a little bit more than half. So 7... So we know 11 is less than half of 23, and 7 is greater than half of 13, thus 7/13 is greater. And so that problem might be a little tricky to think about, but it's basically looking at the denominator and saying, is the numerator more than half or less than half of that number? And so half of 23 would be 11 and a half for that problem. The next problem has us thinking about decimals in this context. So we have 63/100ths cut in half, or cut into two groups. We have 55/100ths cut into thirds, or three groups. So we're going to think about this problem. I know already that 63 is greater than 55, and I know that cutting something into, or putting something into three groups versus two groups will make it, will make this number exponentially smaller than this number. So half of 63, or half of 63/100ths is greater than a third of 55/100ths, because 63/100ths is greater than 55/100ths to begin with. So I'm just trying to use that in context. This last problem here has us taking a whole number, the same whole number, and dividing it by a fraction. So what we've talked about in class is that dividing by 1/3 is the same as multiplying by 3. So this problem becomes 15 times 3. And then over here, this means that dividing by 1/4 is the same as multiplying by 4. So we have 15 times 3 and 15 times 4. In the context of this, right, so if we're looking at it as this problem, so I apologize if I've moved this over and I have not adjusted that. In the context of this understanding, right, we know that 15 times 4 is greater than this. So thus, 15 divided by 1/4 is greater than 15 divided by 1/3. Right? So that's our understanding for this problem. So looking through those and just thinking about how we can explain it without doing the calculation. So it's really trying to get us to think about the mathematics behind that. So our next activity is called a bedroom floor plan. So here's a rough sketch of Nick's bedroom, not a scale drawing. Notice it's not a scale drawing because it's not, the sides aren't straight in this drawing. And so there is that. So Nick wants to create a floor plan that is a scale drawing. The actual length of wall C is 4. So in his actual one, he wants this to be 4 meters, not 4 centimeters. To represent wall C, Nick draws a segment 16 centimeters long. What scale is he using? Explain or show your reasoning. So what I like to do is I like to put the actual 4 meters over 16 centimeters. This is a ratio, right? So our scale can be found writing a ratio. So in this situation, right, I can divide both of them by 4, right? Because 4 goes into 16 and 4 goes into 4. So I can find my scale, so I know that divide by 4 here and divide by 4 here. I know that 1 meter of actual distance is represented by 4 centimeters on the drawing, right? And so that's what we're trying to get at here. So let's find another way to express the scale. So to express the scale, another way we can do is write an equivalent ratio to 4/16. So we can write any ratio that is equivalent to that. So what I can do is I can do 2 meters equals 8 centimeters. That's an equivalent scale. I can also say that, I can also break it down further and say that, 25 hundredths of a meter is equal to 1 centimeter. Like that. So both of those are equivalent scales. And what I did here is I times everything by 2. And on this one, I multiplied everything by 1/4. Discuss your thinking with your partner. How do your scales compare? The scales are equivalent to each other. Because they are equivalent ratios. Right, so that's what I noticed about them. It says, so the actual lengths of wall A and D are 2 and 5/10. So A is 2 and 5/10 meters, and D is 3 and 75 meters. And for B, I actually didn't write this on your paper, but B is 2 and 75 meters. So determine how long these walls will be on next scale floor plan. So remember, we know that 1 meter equals 4 centimeters. So if I have this, right, so for every meter I have here, I need to multiply it by 4. So we're going to start with wall A. So I'm going to take wall A, I'm going to do 2.5 times 4. So 5 times 4 is 20. 4 times 2 is 8, plus 2 is 10. Move the decimal point 1 time, so this is 10 centimeters. Wall B, what we do here is 2 and 75 times 4. 5 times 4 is 20. 7 times 4 is 28. 29, 30. 8, 9, 10, 11. Move the decimal point twice. This is 11 centimeters. And wall D will be 3 and 75 times 4. This is 20, 28, 29, 30. 12, 13, 14, 15. This will be 15 centimeters. And so that's kind of how we take a scale drawing, and then we find the scale. We find another way to express the scale, which is find an equivalent ratio. And then understand that those are equivalent ratios, which is why you can scale them over and over again. And then here, we're talking about taking the actual measurements and converting them to the scale by multiplying them by 4, because we know that 1 meter is equivalent to 4 centimeters. So in our last activity for tomorrow, we're going to talk about 2 maps of Utah, right? And so in this activity, it says a rectangle around Utah is 270 miles wide and about 350 miles tall. The upper right corner that is missing is about 110 miles wide and about 70 miles tall. If you know anything about Utah, you know that in the upper right-hand corner, there is a missing piece of it. And so what we're going to do is we're going to make a rectangle, and then we're going to take that missing piece out of it. So we're going to scale this. So in this one, it says 1 centimeter represents 50 miles. So I'm going to take my miles, and I'm going to divide them by 50. So 270 divided by 50. The great thing about dividing by 50 here is 50 has a 0 in it, and so does 270. So I can get rid of this 0 and get rid of this 0. Because dividing 27 by 5 would be the same answer as dividing 270 by 50. It's just the power of 10 is what happens there. So 5 goes into 27 5 times. And then I'm left with 2. and then I put a decimal point and I put a 0 here. So this is 5 4/10 centimeters. So in the scale drawing, I'm going to use 5 4/10 centimeters for that. That's my width. For my how long it is, or how tall it is, I'm going to do 350 divided by 50. Cross that out those zeros. This is 7 centimeters, right? So that was some easy math for me there. And then this part that they've taken out, I'm going to do 110 divided by 50. Remember, take out that 0 there. This is 2, 1, 2 2/10 centimeters. I'm going to take 2 2/10 centimeters there. And for the next one, we're going to do 70 divided by 50. Take out those zeros. 2, 5, 2, 2, and no, that's 1. My bad. 1. No, 1. 5. 5 times 1 is 5. Then this one is going to be 4. 1 4/10 centimeters. So I apologize for that. I made a boo-boo in my calculation, and I noticed that afterwards. So 5 goes into 7 one time. My bad, friends. So now what we're going to do is we're going to actually measure this. So I'm going to measure a rectangle. And so I tried to give you as much space to draw these, and it turns out that it's going to be kind of a hot mess. So what I'm going to do is I'm going to kind of make my rectangle. So I don't want inches. I want centimeters, because the centimeters this way, well, I guess, but I'm going to make my height of my rectangle this direction. So I want to go 7 this direction. And I know that that kind of goes against that, but I want a 7. I'm just going to flip my rectangle to be 7 that direction, and then it's going to be 5 4/10 this direction. So 5 4/10 this direction so that it fits on the paper, and it might be a little lopsided here, and I apologize for that. So, and I'm going to finish my rectangle. So 5 4/10. So you go 5 and almost up to that line. That's the 4/10 that you're looking for there. And then we're going to go over this direction and close in these lines. And I apologize, it's a little lopsided there. That's my bad. So I have my rectangle. So this is 7 centimeters here. This is my width, 5 4/10 centimeters. Now I'm going to close in. So Utah looks a little different because I made it a little different. So now I'm going to close in Utah up here in this right hand corner. So I apologize for this. It looks a little wonky. So for my how tall it is, so the upper right corner that is missing is about 110. So I need to take out 2 2/10 from the width. Two 2/10. So I want to do the height of this because this will make it a little easier for me. The height, I want 1 4/10. So the height, so that's where I want this to go, and I want this to go inwards about 2 2/10. I want this to be as close as I could possibly be. And then upward. So we're going to take out this part here, and I'm sorry that it doesn't look as perfect as it did before. So this part is actually the part that's cut out from the original Utah, and I'm going to put Utah here. And I only rotated this, so I rotated it sideways, so I apologize for that. The height should be 7, and the bottom pieces should be 5 4/10 because I did not give enough space. So now what I'm going to do here is now I'm going to make a scale drawing where Utah, of drawing where 1 centimeter represents 75 miles. So I have some calculations to do. So I'm going to do 75 outside, 270 inside. So 75 goes into 270 about 3 times. and that gives me 225. Gives me 45. And then from here, I have 45, so then I'm gonna put a decimal point at a 0. And 75 into 450. So I'm gonna try 75 times 6, 30, 42, 43, 44, 45. So that gives me 3 6/10 centimeters. So I know the base of this is 3 6/10. Make the base. Then I'm gonna take 350 divided by 75. I know that 3 times would be 225. 4 times would be 300. So that might be as much as I need. So 300, left with 50. Put a decimal point at a 0. 75 into 500, it would be 6. And you're gonna keep getting 50 again, so it's gonna be 4 6/10 forever. So we're gonna round that to the nearest whole, or the nearest whole number, so that we can measure. So that's gonna round up to 4 7/10. So we're gonna take our ruler, four 7/10. I think I just 4 7/10. So to make this 3, 3 6. 4 7/10, that is right. And then I'm going to close this in. 4 7/10 on the opposite side. I apologize, it takes a little time for this. Let's close this in over here. So that's 4 7. This is 3 6/10 centimeters. And then we need to find out the part that's missing. So we're gonna take 110, divide that by 75. 75 goes into 110 one time. Borrow 5, borrow 35, decimal point. 75 into 150, or 350, 4 times. Right, so 75 times 4. 20, 28, 29, 30, so 300, and then you're gonna get that ominous 50 again, so this is gonna be about 1 4 4600ths, so we're gonna round that to 1 5/10. So I'm gonna take out 1 5/10 of the width, and then I'm gonna divide 70 by 75. Does not go in, add a 0. This is about gonna be 9 times. 75 times 9, 45. 63, 64, 65, 67, 675. You know, we'll be left with 25. 75 into 250 would be 3. And that's 225, and this is gonna repeat. So 9300ths forever. We can round this to about 1. So we're gonna round that to about 1 centimeter. So we're gonna go 1 centimeter down in height. So that's about 1. And then we're gonna go over 1 5/10. take that out. And then this represents the state of Utah. Right, so that's what we're doing tomorrow in class. We're trying to get to this point where we can take a scale drawing and understand what's going on. And so that's the last activity for today. So just a reminder, we went through number talks. We talked about how do we know something's larger than another, which is gonna help us in the future. Talk about scales, so if these two are scales, what do you notice? If these two, if they're written as a ratio. And then over here, we talked about these things. We might use the applet to help us, and then the scale drawings there. So I look forward to see you all in class tomorrow, and I hope you have a good day.